In this video, we are going to look at circle theorems. On the screen, you can see a typical exam question on circle theorems, and by the end of the video, we'll be going through this question. We're going to start by looking at the parts of a circle and give credit to nextlevelmaths.com for this lovely image. So here you can see we've got the radius, which is a straight line from the center to the edge. If you double the radius, you get a diameter, which is all the way from one side of the circle to the other side through the middle, and that's not drawn on this image. Here we have a chord. Chord is a straight line from one side of the circle to the other side of the circle, but it doesn't go through the middle. This section here called the segment, this is part of the circle that is bound by the chord. We have another part of a circle here called sector. Sector is part of the circle bound by two radii. We've got the distance all the way around the outside of the circle that's called the circumference, and then part of the circumference is called an arc. This is the first circle theorem I'd like to consider with you. This is a straight line that just brushes the edge of the circle and carries on its journey. This is called a tangent. And a tangent and a radius always meet at a right angle. You can see the radius and a tangent meet at 90 degrees. Here's another circle theorem I'd like to consider with you. This is angles drawn from the same 2 points in the same segment are equal. So the angle at D and the angle at E will be equal because they're both drawn from the same 2 points A and B. You can see that here. Angles drawn from the same 2 points in the same segment are equal. This is my personal favourite circle theorem, the one that comes up on the exam probably the most often as well. And that's the angle at the centre of the circle is twice the angle at circumference when they're drawn from the same 2 points A and B. So the angle at C would be half the angle at O. You can see here, angle at the centre is double the angle at circumference when they're drawn from the same 2 points. This is something called a cyclic quadrilateral, which is a four-sided shape inside a circle. And what's important here is the opposite angles add to 180. So angle P and Q would be 180, and separately X and Y would be 180. Opposite angles in a cyclic quadrilateral add to 180. There's another circle theorem here, which is opposite a diameter is always a right angle. An angle opposite a diameter is always a right angle. And the final one I want to consider here is this one called alternate segment theorem. The angle in the alternate segment is equal. Angle in the alternate segment is equal. We're now going to have a look at a couple of examination questions quickly. It says A, B, C and D are points on the circumference of a circle with a centre O. AOC is 168. Find ADC, which is this angle here. We've got two ways of approaching this question. We could find this angle here. So if that's 168, this would be half of 168, because we've got angle at the centre, angle at circumference drawn from the same 2 points. So half of 168 is 84. And then we've got opposite angles in a cyclic quadrilateral add to 180. So this one must be 96. The other way of doing it is to consider angles around point and find this angle here, and then that would become the angle at the centre for that one to be the angle at the circumference. So find this one and half it to get 96. Very, very similar question here for you to do. Press pause and have a go. Right, this question here. This time we're given the angle at the circumference, and if we times that by 2, we get the angle at the centre, which is 140. And we've got 70 here. This one is the opposite angle in a cyclic quadrilateral, which gives me 110. To check, I could find this angle here, which is 360 minus 140, which is 220, and half of that is 110. This is a lovely question here, which I'm just going to finish with. I've got here a tangent and a radius that meet at 90 degrees. AOD is a right angled triangle that sums to 180. So we've got 90 and 36 is 126. Leaves me with 54 degrees in the triangle. Then we've got angle at the centre, which we would half to get the angle at the circumference, which is 27. With circle theorems, make sure that you write your reasons out in full using all the keywords that we've discussed in the video. All the best, and follow us at Griffin Maths for more maths help.